I'm going to walk you through my second 4-inch long range build. I know this is an old thing and some people have kind of given up on this whole concept, but I was really taken by the Dave C 4-inch long range thing. And so ever since I saw it, I've wanted to build one, and I couldn't afford it at the time. And so now this is now my second build. The first build flew away, or didn't fly away, just fell out the sky. I don't know what happened to it. I might have done a return to home to some unknown location. Anyway, so some of this is super budget. And then right at the end, I had enough money to get another Reaper Extreme. So some of the stuff on here is not so budget, but yeah, so I've saved some money here and there. So some of it's cheap, some of it's not so cheap. But you can go through this build and just kind of pick and choose the little bits that might be interesting to you. I think the first thing to point out is that I have gone for the proper long-range motors are the 2750 kV motors that Dave C used. And I used some HG LRC motors in my previous build, which are a wider and lower stator than these. These are 1504 2300 kV motors from Darwin FPV. After inspection, you know, they are cheap motors. They've got thinner wires. They don't feel like they've got as strong magnets as the HGLRC that I used before. So definitely those motors were better. But I am interested to see with a higher stator and lower kV if they'll sort of cancel each other out and give the same performance. So that'll be an interesting little test to see, and wait for the end of the video for my flight test to check if those are working well. So I'll fly them and see how warm they're getting to see how efficient they are. Okay, so that's that. The frame is a very, very cheap frame on Banggood. It's the RAN4 frame. And you know, the only downside is with a cheap frame like this is the edges aren't chamfered and the edges aren't prepared. So I found an old blog post where it explains to you how to prepare these carbon fiber frames. So what I did was I sanded the edges, made sure that they're not too sharp. I didn't get it right everywhere, like these small holes. I am still worried that some of the wires are going to get damaged through these small holes because the edges are so sharp. But you sand the edges and then you actually use super glue to seal it. So you use super glue as a sealant, and then that will make sure that you don't get any like sort of perforations on here. And it does feel a lot better than when I first got it. That's how you prepare a cheap frame like this. Now overall, the frame is actually quite nice. It's still got the thick arms. It's got these sort of studs that Dave C originally brought to the concept, and it comes with a lot of TPU parts. So it came with this lovely camera mount here. It also came with the GPS mount, but I actually ended up with a smaller GPS module, so I just got a different printed. Came with this lovely antenna mount here, so I made sure that I got an antenna that fit this because it just is very nicely printed and ready to go. It does have little feet to put on if you like putting feet on your drone. I'm going to leave the feet off to save time, save weight. The standoffs are a little bit on the skinny side and on a little bit on the flimsy side, so if you did want to replace the standoffs, that would probably be a good idea. And it came with a whole lot of other 3D parts. Like this is a GoPro mount. That is quite a nice 3D printed mount for the camera. And it had two options on the FPV camera mount. So you've got a thinner one and a thicker one for, you know, wider and thinner FPV cameras. And then the pad for the battery it's not very rubbery. It's actually just soft. But I do find a soft pad will grip because it kind of makes an indentation when you strap the battery on, and then it grips quite nicely. So it's got a good grip and it's soft. So that won't last very long, but it will work quite well. And it's cut to size for the top plate. Okay, enough about the frame. Let's talk about the parts and how I'm going to fit everything. Let's just do this. All right, so I do actually just have old Caddx FPV EOS version 2 on here from an old drone, so I saved a bit of money there. I'm using a Secure with a Q. I'm using that as my LRS receiver. Also a little bit on the budget side, but it does seem okay. It does look a little bit cheaper made with slightly cheaper cables. comes with a lovely antenna, and I've had these antenna mounts printed, which pulls the antenna away from the drone a little bit, which helps with interference. The further you can get your antennas away, the better. So that helps a little bit. I'll put all the 3D printable parts that I did extra. I'll put them in the description. Then the GPS is... the jury's out on this one, but I used it's called a Solo Good GPS. It's the only one that I could find at the time, and I was trying to save money. So let's just see how that one works with the field test. I've used a Flyfish MMC-X antenna. So it's the one where it's got the pipe here to hold the antenna, and then the cable comes out. Now, it is a right angle connection, but if I put the VTX this way and had the connection over there, this antenna would actually go too far. It starts here, and then I can't connect it into here. So I just turned the VTX. I got a little bit of distance on the cable, and then this fits in here. On the bottom, I printed a nice little TPU mount for my buzzer, which is something I didn't have on the previous build, which just secures it nicely. It makes it look neat. It protects a little bit because it was getting scratched at the bottom of my drone, and I put the beeper at the bottom. And then this comes with 3 cables, and I'm going to check and I'll confirm when I'm doing my build, but this flight controller just has a buzz minus and a buzz plus, and so I don't think I need the third data cable. I think it's just going to work straight from the Buzz 1 and Buzz Plus. That is just a sticker from SGLRC. Now I've gone for the Reaper Extreme again. This is a very powerful analog VTX. I had the 2.5 watt last time, and I will explain how to create a switch on your controller so that you can switch the power rating as you take off. So have it at pit mode when you take off. As you take off, it goes into, let's say, 400 milliwatts, and then jump it up to whatever, 800 milliwatts, and then when you're out and about, you jump it up to 1.8. This is a 1.8 watt. And then the flight controller. I found a really cool FPV guy who made this flight controller adapter. It's got all the holes for different mounting sizes, and then it mounts to a 26.5 on these AIOs. And what he's done is he's actually created the mounting points for the AIO with the TPU. Now, you would think that wouldn't work, but when you put your sort of mounting gummies on there and you stick it in there, it is stuck. That is not going anywhere. And so this is a really, really nice adapter. I'd highly recommend it. So if you're looking for a really good AIO adapter, this is the one to go for. I'll put his link in the description. Now, in terms of mounting, the flight controller, I am going to mount it the correct way this time. Last time I made it, I had to rotate it in Betaflights, but I'm going to have it on there. But I'm going to put the capacitor inside, and then all I'm going to do is I'm going to put it in there, have this in there, and then bend those over, because this nice thing about this flight controller is that it has 2 tiny holes here to put your capacitor wires into. So I don't know if you can see those tiny holes, but I'm going to get those capacitor wires in there, kind of bend it into place. The capacitor will sit nicely in this little hole here. There's a perfectly sized hole at the bottom here, and then I'll just bend it over, and that will be perfect. And last time I mounted the power supply there, I'll see. I prefer to put the power there, running there, so that to avoid any sort of interference from the current to the VTX and the GPS and the antenna here. So I think I'm going to do that again. And then in terms of the soldering, so this was the nice thing about this JHE-MCU flight controller. It's an F7 flight controller. It's not too expensive. The only downside is that it's micro USB and not USB-C. That's really the only downside, but it does come with all the goodies. If you really are offended by the micro USB, it comes with USB-C adapter, and you can solder that on. Comes with all the cables, all the gummies. This is an XT60 connector. I think I might go with XT30. I've got a bunch of connectors here, so I might just go with XT30. So this flight controller comes with a practice pad, which is great, because if you are a newish to soldering and you're just getting better and better as you go along, but it's still new to you, this will be a good practice, because as nice as this flight controller is, everything is quite cramped. Let's have a look here on the actual flight controller. So you've got solder points on the edge here, over here, and over here. So you've got a solder here, here, and here in 3 rows. They haven't used a lot of the real estate, like it's all full of like little microchips and stuff. So all your solder points are on the edges, and then you've got this like sort of stacked solder point thing here. So it is very difficult. And what you want to do is, let me just show you the practice pad. I practiced this weekend to make sure I know how to do it so I can do it during the week. So you want to start on the outside. You want to do the edges. Then you want to move into here. So I've done one here, start here, and then move it to the sort of next tier there. Now the edges, so this is like your normal soldering, heat the pad, put your solder on, tin it, tin your wire, and then solder. That's normal, it's just stacked and it is a little bit tricky. The new skill for me was using these edge solder points. And I wasn't sure how I need to do it. So the motor ones are quite big and almost too big on the actual flight controller. But anyway, so the motor ones, you've got to put your soldering iron where my screwdriver is, heat the pad, and then get your solder in there and let the solder go in until you see a little glob forming in that little groove there. Once there's solder in that groove, you can actually put your tinned cable. So then you put your soldering iron here somewhere and heat it from above, but then you put your cable in from the side. And you just make sure that you've got it like going into that groove. And once the solder is soft, the cable will go in and it'll just go into that little groove. So the end of the tinned bits of your cable can't be that long. But you put it into the solder, make sure it goes into that groove, release your soldering iron, and it'll harden and it'll go into that groove. And it's actually, like, compared to doing normal soldering like here, it's probably some of the easiest soldering I've ever done because, I don't know, it just seems it's very easy. So at first it was very intimidating. Turns out to be quite easy. Now the difficulty here is because I've got these cheaper motors, and these are sort of unusually large grooves for motor wires. I'm going to have to put a huge glob of solder in there and then put my tiny little wire in there. But anyway, it'll work. I'll just put a nice long piece of tinned wire in there and have that soldered in. But like I say, it is actually easier than you think to solder this. Just get your soldering iron on the top and your wire in from the side. All right, so I'm not going to film the actual build. I'm still like, I'm not an advanced builder and I can't film while I'm building, but I'll try to take photos and show you any pitfalls that might have occurred. And then we're going to do a flight test. I'll do a week of testing, and then I will let you know my findings, like whether this GPS is any good, whether these motors are efficient enough and all that. So I might do a few upgrades in the months to come, but I'm pretty happy with where I ended up with this drone so far. Hey everyone. Okay, so the test now is to check the GPS. I'm at the park. I'm just going to fly around the park. So I'm checking the GPS, making sure the VTX is working all right. What I've done is I've put the VTX to a switch. So I've got a switch on my controller that will control the power of the VTX. So it'll jump from, I think, 400 to 1 watt to 1.8 watts. So that is very nice. As you'll see on my OSD, I've got all my bits and pieces. On the right-hand side is my battery. That fly at the bottom right is the timer 2. So timer 2 will give you your time from arming. On the left, the top, the 25 is my wattage, so that is in pit mode at the moment. Then you've got your satellite, so it's up to 6 now. It's taken quite a while. This is a new spot and it is a slightly smaller GPS, and I'm under the trees as well, so I'm not giving myself the best chance here. Then I've got distance to home. Then I've got, I think that's flight distance or something, I'm not sure. I think that's a speed, I just wanted that for fun. And then the bottom left, I've got my altitude, but it's got a barometer, so it should be able to work out the altitude quite nicely. You'll see my latitude and longitude is set there. And just waiting for it to get to 8 and locked on 8. There we go, so we're at 9. So we're going to fly around the park. So VTX, GPS check, and return to home check. So let's give it a go. Okay, so we got, similarly to my previous one with the fancier motors, I've got a low throttle, like the throttle only needs to be under 50% for cruising. I would like that to be a little lower. I reduced the rates. I did a Flyway Explorer tune, so there was a guy who just shared the tune of the Flyway Explorer on YouTube, and I just copied that. But now these are different motors, so I have a feeling these are 2300 kV, so lower kV, but higher stator, narrower bell to the motor. So we're going to have slightly different performance, and I think what I'm getting is I think higher revs. I might be wrong, but I have already turned the rates down, so I'll just do like a flat rate that I just turned down on all the rates, just try a little bit. I think I turned it down by 20. Let's go up to 1 watt. There you'll see it goes clearer immediately. I'm not super confident to do gaps with this, but let's just see, just to test the penetration here on the 1 watt. That's okay. All these motors sound great. Okay, so here, let's do a return to home and see what happens. Okay. And yeah, that's good. It's flying home. I've got the Caddx Anton here, that EOS that I had, the old EOS that I was going to use, EOS V2. Didn't work. Let's see. That I think the thing with this 500, so you know, in the close range, I'm getting quite a bit of breakup and all that sort of thing. But I'm under the tree. I'm not even facing the drone. And let's just see. Like, it's super clear now. Like, I've flown further away from myself. I'm getting better signal. So in actuality, this Foxeer Reaper is actually quite good for long range, because like, it's not great around the park, but when I fly far, it lets me go far, if that makes any sense. All right, so this little GPS is working well. This flight controller is really nice. It's an F7 flight controller, and it's got a lot of UARTs. I was able to wire everything up really nicely. Those intimidating solder pads are actually fairly easy once you get the hang of it. There we go. Okay, low battery, just going to command. So far, so good with this GPS, man. And I do think, like, that return to home just felt better than my previous drone. So I think the barometer really helps. In conclusion, things that I thought that weren't so cool about this build that ended up being fine. This antenna, it is a little short, but as you can see, when it's flying, when it's like there, you're still getting over the battery. So even though I do see a little bit of breakup when I turn around, it is fine. Could have been longer, but this Flyfish antenna is very good, this Osprey antenna. These Darwin FPV motors, definitely a compromise. They're not as good as the more expensive motors, but they aren't heating up. They're very efficient. I'm getting great flight time. I think the longest flight time I've gotten so far is about 9 minutes. So it's a little bit less efficient than the previous motors, those HDLRC Spectre motors, but they're great, you know, doing really, really well on this build. The other thing is foldable. Like, a lot of people go, oh, you would never need a foldable drone. This makes it very compact and easy to put in my camera bag. I use my camera bag for my drone, and I can just put it in the bottom part of the bag, and it works really well. And because it's a long-range drone, you know, I do maybe sometimes tighten these screws when I get there, but as long as it's sort of tight to the touch, you're not going to have any issues with it breaking, and because you're not doing like crashes or anything with this, so you should be okay with that. As you can see, I now have my lithium-ion battery that I've built, so that will be in a new video. I haven't tested that yet. That's literally I've just strapped that on now. I don't have a big enough strap, so I'm just using this for the time being. This flight controller, what's it, JMCU, so far so good. Very nice flight controller. It was very nice to solder this one up. I glued in the USB-C port over there. I ended up I had to have it because the micro USB port was actually behind the the standoff. So I had to put the USB-C extension in there. GPS working well. It takes about 5 minutes to get a full GPS lock. I'm going to go through my Betaflight setup in another video because there's so many things I learned in this build from some friends and research and all that, so that's going to be in another video. This SOTA beeper, just an announcement, like a sort of public service announcement, it has broken. This button broke. So I've unplugged it because if it gets a charge, then it just starts beeping like crazy and I can't switch it off. So I'll just plug it in when I do, when it's time to fly. Things I'm not happy with. I'm not happy with the tape that I've used. I would like to get a those little proper things to stick on here, or those braided things that people use. This is not ideal, this tape. And in terms of flight characteristics, it is very, very nice to fly. Very floppy. The tune that I got from the Flyware Explorer, the drone likes to stay level, which is what you want. You can feel it doesn't want to flip over and that, which is great. It's a nice, stable build. I'm getting good, stable signal. This Foxeer Reaper that I've installed in here is great. And that's it. Happy flying.